about to make some chocolate chip cookies, but I'm going to make them for all of you at school, so I need more than I would ever make at home. So we're going to talk about fractions again today, and fractions are part of baking, part of building, and I have all my measuring cups here, and my recipe tells me how many cups of sugar I'm supposed to have, and how many cups of flour, and how many eggs to have. But for our measuring cups, for example, a half a cup. I need half a cup of sugar, but if I'm going to make a triple batch, then I need 3/2 cups of sugar. So I can add those together, but I can also multiply the fractions together too, 3 by a half. Or if I have 3/4 of a cup, like I need 3/4 of a cup of brown sugar. If I'm going to triple it, I need to have that multiplied by 3. So those are other places that we can use multiplication, and we can use fractions at the same time. So that's what we're going to talk about today. We're going to talk about fractions, but we're going to talk about more specifically multiplication of fractions. So that's what we're going to talk about today. All right, so let's get started, and I'll get started on the cookies after I'm done talking to you. All right, so coming around here, let's just switch around to our easel over here. All right, so multiplication and fractions. So multiplication of whole numbers, we remember doing that in probably grade 3, grade 4. And for example, if we had something like 6 times 4, we had 6 times 4, and we often started using the area model so we could get an idea of the concept of it. And we may have put our 6 blocks on the side here. Put another one up there, and another one down there. Make sure you can see all those, yeah. And then 4 across the top. Actually, we'll put our 4 across the top here, and we'll put one extra 6 here. So we have 6 here. 1, 2, 3, 4, 5, 6. So here's our 6 here, and then we have 4 across the top. All right, and we can make that into a rectangle. So we'd have here's our 4, and then our 6. So we have 6, and by that we could count them up, or we could do the multiplication, 6 times 4. But when we were first learning, we would have counted them up, and we would have seen that there were 24. And then we would have learned from that 6 times 4 equals 24. Well, the same concept goes with fractions. The difference with fractions is when we multiply two whole numbers together, we usually get a larger number. For example, we just did 6 times 4 equals 24. If we multiply something like 3 times 9, we get 27, a number that's bigger than those two, because we have 9 groups of 3, 4 groups of 6. But when we multiply fractions, specifically improper fractions, so we're talking about something like 1/2 times 2/3, we're going to get an answer that's actually less than 1. And the rectangular model of the area model using a rectangle is a good way for us to understand the concept of why this is true, and also to help us when we do word problems with fractions and multiplication. So let's just start with an example. All right, so let's start with 1/3 times 3/4. Okay. Now, when we did whole numbers, we learned that, for example, if we were multiplying 3 by 4, we would say 3 of 4 groups. So here we have the same thing. It's written as it can be also said 1/3 of 3/4 is the same as what we have written here. All right, so let's start off with a rectangle. And the first thing we're going to do is start off with a rectangle. And we want 1/3 of 3/4. So first of all, we're going to start with some vertical lines and divide up our rectangle into fourths. We're going to start with our 3/4. So I always like when we're doing fourths is to split in half first, then do 2 more halves, and then I've got pretty even fourths. They're not perfect, but they're pretty good. So to represent 3/4, we just color all 3 sections. So now our rectangle represents 3/4. Now we want 1/3 of 3/4. So what we're going to do now is we're going to draw horizontal lines through our 3/4, and we're going to go right to the outsides of our whole rectangle so that we know what each part of our rectangle is now going to represent. So we're going to divide this into thirds. So there's one. So now we have, horizontally, we have thirds. And it says we want 1/3 of this 3/4. So let's draw 1/3 of this 3/4. So we have 3 boxes. We're going to color off 1/3 of them. Okay, so let's see here. So if we do the top, let's just do the top. Okay, so there's what represents 1/3 of our 3/4. Now, the part where the shading overlaps, that's our product. Our product is this shaded part right here. So what our product will be, what it will look like as a fraction, so that equals our number of parts over the kinds of parts. And what do I mean by the kinds of parts? Well, the kinds of parts, now that we have partitioned it off into thirds and 3/4, we now have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and then 3 this way. So we now have 12 parts, don't we? 12 equal parts. So that's what I mean. The kinds of parts are 12 now. When we just had 3/4, we had 4 as our kinds of parts. But now we have 12. So that's what we do after we partition off all of our lines, both horizontally and vertically, and we see how many parts we have. So that's 12. And how many parts do we have overlapping? We have 3. So our product is 3, these 3 overlapping, over our 12 kinds of parts. Now we could simplify that and we could say that that was 1/4, but 3 over 12 is still the correct answer as well. All right? So that's how we do area model with fractions. Let's try another one. Why don't you stop the video now and go get yourself a piece of paper and a pencil, and you can do it along with me. All right, welcome back. All right, the second one we're going to do is 2/3 times 1/5. And remember, this is the same as saying 2/3 of 1/5. That's that's a way of writing out the product. Okay, so first of all, we always start with our rectangle. So let's start with our rectangle, and we're going to use our vertical lines first, and we're going to represent the 1/5 because we want 2/3 of the 1/5. So first of all, we've got to figure out what that 1/5 looks like. When I do fifths, I always do a little line at the end, then I split this part in half like it's fourths, and it doesn't always work perfectly, but not too bad. So there we have fifths. So that's our fifths, and we want to color off 1/5. So let's color off 1/5. All right, so there's our 1/5. So that's our rectangle represented in fifths, and 1/5 is colored off. All right, so now we want 2/3 of that. So now we're going to do horizontal lines, and we're going to mark off, partition our rectangle horizontally in thirds. All right, so let's do that. Horizontally in thirds. And we're going to go all the way across so that we know what each part in our whole will now represent. All right, so we want 2/3 of this fifth. Well, we can see we have 3 parts. Now we want 2 of them colored off, so we'll do that. So 2 colored off, so let's take these top 2 right here. Now, as we said before, the product of this is the parts that are overlapping. Okay, so we have 2 parts overlapping. So remember, our product is the number of parts overlapping over the kinds of parts. Okay, so how many kinds of parts do we have? Let's see, we have 5 going this way, There's 5 this way. There's 3 this way. And from our whole number area model, we know that 5 times 3 is 15. So our kinds of parts are 15. And how many are overlapping? 2. So the product is 2 over 15. So we can write that up here if you want. 2 over 15. That is the product of that. All right, let's try one more. One more example. All right, so our next example is going to be 4/5 times 1/4. And while we're just learning, we're just going to write it out as 4/5 of 1/4. So we know this is what we want. We have it first, and we're going to take 4/5 of that. So let's start with our rectangle again. And we're going to partition that off vertically in fourths. So we split that in half, then split that one in half, split that one in half, and we want one of those. We now have our rectangle split in pretty much 4 equal parts, not perfect, but pretty much. And we're going to take one of those. All right, now we want 4/5 of that. So we're going to make horizontal lines, and we're going to split it, partition it in fifths horizontally. So I'm going to draw my one line there, and then I'm going to split that one in half. There we go, and there we go. So now we have fifths. Now we want 4/5 of this. You can see we have 5 different boxes. We want 4 of them shaded. So 4 shaded. We're going to go 1, 2, 3, and 4. So again, our product is the number of parts that are overlapped, have the shading overlapped. So the number of parts overlapping over the kinds of parts. And that's our denominator. So that equals, so our number of parts overlapping, 1, 2, 3, and 4. And the kinds of parts, well, we have 4 here, and we have 1, 2, 3, 4, 5 here. So we have 20 parts. And we could count them all up if we wanted to, just to make sure. So our product is 4 over 20, which if you would like to reduce it would be 1 over 5. Or simplify it. So our product is 4 over 20. So on the flip grid, you'll see this video. You can revisit this video anytime you want. There also will be a response video for you to do this week as well. There will be 3 problems similar to this. And what I would like you to do is to solve those 3 problems and to illustrate the solution by partitioning a rectangle. And you can do that right on the video. There's places on the video where you can draw. So you can draw your rectangle, and remember the rectangle represents the whole. And just tell me your reasoning and how you went about solving it as you show me your illustration of the problem. So there'll be 3 of those in the drop-down section of the topics after the topic focus. As well, I'm putting a couple links this week for you for reading, because I'd really like you to do some reading. On audible.com, which is run by Amazon, there's free audiobooks for youth for right now, right through this pandemic that we're having. It's all free, and they have so many choices for you to read. And as well, I'm going to give you a link to an app, a free app called Tinkercad, and it's tinkercad.com, but I'll put the link there for you, and you can do 3D designs there, and you can do coding there, and it's really quite fun. So I thought you might like to do that as well. I hope you have a great week, and I look forward to seeing your video responses. And remember to check Flipgrid for this video and for all other resources that I put there for you. Thank you very much. Bye-bye.